This next section is 15.2 under the general section of linear superposition and interference of waves, and we're going to talk about how waves interfere with one another. And if we think about waves and the different paths that they may take, if I have one wave here and another wave here, if they get to a point and the delta x between these two paths is equal to an integer times the wavelength, they started out in phase, but they moved by different paths, and the difference in the two path lengths, and these are the same frequency, they start out together, but they curve around so that this wave may go, it meets with this one, sound is forced along here. If it's an integer multiple of a wavelength, where n is equal to 1, 2, 3, and so forth, then in fact we call this constructive interference. Interference is constructive. And that's because the path difference has given us exactly one whole wave to get back in phase. So these waves would then be such that even though the path was different, and this may have gone through different oscillations, they have differed by exactly an integer wavelength. If, however, the path length for two waves going in different paths differs by a delta x, which is an integer and then another half of a wave times lambda, where n is equal to 1, 3, 5, and so forth, then we're going to get destructive. In other words, we would have an integer like 1.5, or any number of half wavelengths that are extra. Actually, this could be 1 or 2 or 3 or 4. I think that's a typo there. So anytime I have an integer number of wavelengths and then another half of a wavelength, then in fact I'm going to get destructive interference. Destructive interference arises when I have an integer number and then another half of a wavelength. Now I can get interference from a single slit, and this arises because if I have a single slit and I have a wave that goes through, part of the wave that's going from this point and the wave that's going from this point, or let's say halfway in between and down here, they're going to differ by a certain amount and give us constructive or destructive interference at this point. Let's imagine that we look at this angle, or this angle here is theta, and if we look at, if that is theta and we drop a perpendicular here, remember these are generally small angles, then this angle here will also be theta, because as we bring this back, get 90 degrees, the angle between this and the parallel will go to 0, and this in here will go to 0. Now we can say this path length here differs from this path length here by a certain amount. It is going to be such that I get interference if the sine of theta is equal to a wavelength divided by the distance. Why is that? Well, if this is the width of the slit, d, and d, this distance right here, is going to be d times sine theta, then you can see that this part here will be one wavelength away from this part here.